So here we are today continuing our conversation about these mirror and magnification equations. So this is the second of two screencasts on this topic. So if you missed the first one, you're going to want to circle back and watch that first. Now, typically students find that the magnification equation is a little bit easier to work with. So that's a good thing. So when we think of magnification, hopefully you're thinking about changing the size. So in the case of optics, we're looking at whether the object, the image is going to be larger or smaller than the original object that's placed in front of the mirror. Okay, so here is our general equation. You know, HI, H meaning height, and then so HI divided by HO, okay, so the image height divided by the object height is equal to negative DI over DO, where DI is the image distance and DO is the object distance, just as we saw in the distance equation before. Okay, so we're going to talk a little bit more about some of the details here. Notice that there is a negative there. So that negative, remember, can be assigned either to the numerator or the denominator, but not both. You know, so when you're doing your calculation, make sure that you take that into consideration, but we'll see that when we work through some problems in this section. So there's a couple of other details, just as we saw with the distance equation, around positive and negative values. So let's take a look at that before we dive into our word problems. So something that's very important to note in terms of how we interpret the answers that we get when we perform these calculations is that a positive image height, okay, so in other words, if you get HI, that is a positive value, that means your image is upright, okay, compared to the object, okay? If you have a negative value for your image height when you do your word problem, and the result is a negative value, that means the image is upside down or inverted. So for example, if this had been the scenario in question where we worked through a word problem and our image right here you know, is in this spot, I can tell it's inverted. So any height value that I would get from that, I would expect to be a negative value, and that would just confirm that indeed the image is inverted. Well, this will hopefully become more clear as we work through a word problem or two in the next section. Okay, so in this case here, I'm going to read through the question with you. We're going to start off with a fairly straightforward example, and then we'll navigate into some more involved questions. So in this case, it says calculate the image height for an object with a height of 2.5 centimeters placed 12 centimeters from a concave mirror if the image distance is 17 centimeters. Well, for a short sentence, that is jam-packed with information. So I don't know about you, but for me, I really need to write out some givens here to get oriented about what I have and what information I need to figure out in this question. So I'm going to do just that, and I'd like for you to try the same, and then we'll meet up in a second. So pause the video and give that a try. So I find, you know, a highlighter or just a different colored pencil is super helpful for me to highlight, well, what information do I have and what information am I looking for? So it says right here, calculate the image height. So image height for me is HI. So that, you know, right off the bat in my givens, I'm going to say, well, HI, that is what I don't know. And so right now, the only equation that I have with HI in it is that magnification equation. So I know that that's going to have to be involved. Let's keep going here. So it says for an object with a height of 2.5 centimeters. So that tells me that my object has a height of 2.5 centimeters. So that's my HO, 2.5 centimeters. Okay, and then next it says placed 12 centimeters from a concave mirror. So that is meaning that my object, this object here, is 12 centimeters in front of my concave mirror. Okay, so that tells me right there that that is my DO. Okay, and then finally they're saying if the image distance is 17 centimeters, so that is my DI. So there I have all of my givens. Hopefully you did okay with that. And if you didn't, hopefully that layout makes sense. So now the only tool available to me that relates the given information is our magnification equation, right? HI over HO is equal to negative DI over DO. Now this negative here is part of the equation. So if I had a negative value for either DI or DO, then I would have to, there would be two negatives, and then I'd have to think about what that means mathematically. Maybe we'll see that. So HI is my unknown, but I'm going to substitute in all of the other information here. I have 2.5 centimeters. Negative DI is 17 centimeters over DO, which is 12 centimeters. So now, since I am dividing HI by 2.5, to get rid of that 2.5, I'm going to need to multiply by it. And whatever I do to one side, I'm going to do to the other side. And that allows me to nicely see how those 2.5s will cancel out. And so just typing that into my calculator, HI is equal to negative 3.5 roughly centimeters. Good. So now, what does that tell me? Well, that tells me that, my image happens to be inverted, right? So if I were to draw this out just to make sense of my answer here, here's my concave mirror, and I've got my image and my object that are on opposite sides of the principal axis, right? So if my object height was 2.5 centimeters, then my image height is larger and inverted, right? So I can think about how that plays out on that, because I'm also given information about the object distance and the image distance there. Okay, hopefully you did okay with that. Let's try a second example. Okay, so this question has multiple layers to it, parts A, B, C, and D. So let's start with what I'd like you to do is to try parts A and B first, and then we'll take them up. But let's read out the question first. So it says a concave mirror has a focal length of 6 centimeters. An object with a height of 0.6 centimeters is placed 10 centimeters in front of the mirror. And they're asking for the image distance, and they're asking for the image height. Okay, so go ahead and give those two components a try, and then make sure that you're okay with those. We'll check them together before we move on to talking about C and D. So pause the video, attempt part A and part B, and then we'll take up those solutions together. Okay, so I'm going to draw myself a little diagram here. It says I have a concave mirror, so I'm going to draw my concave mirror. And it has a focal length of 6 centimeters, so there's my focal length of 6 centimeters. And in fact, I can write that out as a given, right? So that tells me that F is equal to 6 centimeters. And in fact, I know that F is positive 6 centimeters because it's a concave mirror and the focus is in front of the mirror. Okay, an object with a height of 6 centimeters is placed, so that's my object with a height of 6 centimeters, so that tells me that that is HO, so I'm going to write that out. Oops, 0.60 centimeters. Is placed 10 centimeters in front of the mirror. So that is my DO. Right? And so in part A of this question, I'm asked to find the image distance. So if this is part A, then I know that what I'm looking for is di, right? And so at this point, you might be thinking, well, how do I know which equation to use? So I'm just going to take a quick moment to talk about that. Well, the magnification equation was high over ho equals negative di over do, right? And so if I'm looking for di, right, then I need to have all of these other unknown, like these other variables, right? So do I have do? Well, yes, I do have do. That's good. Do I have ho? Yes, I do. I have that. But the problem is I don't have high. And so that is what's telling me that is not the right tool to use in this case. So in this case, what I need to do then is just to, take a look at my other equation, which is my distance equation. So that is, of course, 1 over f is equal to 1 over di plus 1 over do. So substituting in all the known values, 1 over 6.0 equals 1 over di plus 1 over 10 centimeters. Now to isolate my di, I'm going to take this 1 over 10. And so rearranging this equation, I have 1 over 6.0 minus 1 over 10.0 equals 1 over di. Now I'm just going to take a minute to figure out what 1 over di is, knowing that that's not actually my image distance, it's the reciprocal. And I'm getting 0.067. Well, I'm going to actually make that 0.0667. And then I'm going to use my x to the negative 1 button to find out what di is. And so when I press that x to the negative 1 or my 1 over x button, I'm getting 15 centimeters as my answer. So let's just analyze this, right? So I have my object, my focal length, which is at 6 centimeters, and my object distance is at 10 centimeters. So if I wanted to kind of illustrate that, it would be around here. And this is telling me that my image distance is at 15, right? So way back here. And so that makes sense because, if my focus is at 6 centimeters, then my center of curvature is going to be at 12 centimeters, right? That's C. And so it makes sense that if I have an object that is between C and F, that my image is going to be behind C, which it is at 15 centimeters, right? 15 centimeters is beyond 12 centimeters. So hopefully you did okay with that. What I want to do next is just take up your solution to part B. So what I've done is I've written out all of our known values now, and in fact I've included in our list of knowns that di, that image distance that we figured out from part A. So now we're ready to go on and look at solving for part B of this problem, which is to calculate image height, or HI. So I'm going to write that over here in our list of, this is my required to find is my HI. Okay, so the equation we use is HI over HO is equal to negative DI over DO. So now all I have to do, this is pretty straightforward at this point. I just need to substitute in my known values. Okay, so my image height is 0.60 and my image distance is 15 centimeters. Oops. Leave that unit out if I want to. And then my DO is the 10 centimeters. And so now in this case, that negative is there as part of the formula, and neither of the values I'm putting in here are negative. So let me go ahead and just isolate HI. I'm going to multiply by 0.60 on each side of the equation in order to cancel out it out on the left hand side, and that allows me to solve for HI. And so I'm getting for HI at 0.0 0.90 centimeters. That's what I'm getting for my height of my object. And so, you know, we're going to put all of these pieces together in the next two little bits where we have to calculate the magnification and describe the image characteristics. Hopefully you did okay with those two first components. So right now what I want to do is I want to address part C of this question, which is calculate the magnification. And so what we didn't really talk about outright is what magnification is. Well, magnification is really just how big the image is compared to the object. And we already have an equation for that, right? So, you know, magnification is really just that equation we already know. It's the ratio between the image height compared to the object height, or it's the ratio of your image distance as compared to your object distance. So we can use either of these to end up with our magnification for this particular case. So the magnification we know is HI. HI ended up being 0.90 centimeters in the last problem. And HO ended up being 0.60 centimeters. So that's all the magnification is a ratio of how big is my image compared to my object. So when I perform that calculation, I end up with 1.5. So what does that mean? Well, that means that my HI, therefore my image, is 1.5 times the size of the object. And that's it. So that's it for magnification, right? So really it's just the ratio of, well, the image compared to the object in terms of height or in terms of distance. So now I want to talk about this last little bit, which is describing the image characteristics. And that's actually going to ask the most out of us in terms of our thinking about putting these pieces together and making connections to some of our previously learned knowledge. So let's take a look at that. So what I want to do is that what I've drawn here is I've drawn a, So what I've drawn here is a concave mirror, principal axis, and what I've done is I've summarized all of the information that we have gained throughout this question, through working through this problem. And so I want us to kind of, it'll help us to visualize the image characteristics if we outline some of these details on a light ray diagram. So I'm going to do exactly that. So, you know, my focus, I'm not measuring, this is not to scale, it's just simply to help me understand where things are with reference to other parts of this problem. So if I say, for instance, here is my focus, right, and that focus is at 6 centimeters, right, then I know that my center of curvature is going to be where? Well, it's going to be at twice the distance, right? So that's 12 centimeters. And this, by the way, should be a capital F. Okay, so now my object distance, they're saying, is 10 centimeters. So, you know, I'm going to just rough that out and say that my object is roughly about here, right? This is my DO, and it's at about 10 centimeters from my mirror, right here. Okay, and my DI is 15 centimeters. Now, my image is going to be 15 centimeters. So if C is at 12 centimeters, then DI is going to be like back here somewhere, right? So DI is going to be at 15 centimeters. Now, I'm noticing now that what I forgot to do in the last section, and so I'm just going to switch back to that slide. Let me see if I can find it, is that I forgot to include the negative here, and that this value should actually be negative. And so I'm going to switch back to the slide and put a negative here. because what that negative is telling me is that my image should be upside down compared to my object. It should be inverted, right? And that's not surprising to me because I know that, you know, if I have an object between C and F, then my image is going to be beyond C. Now, and it should be inverted. And so the fact that it's inverted here is important, but also looking at its size, right? So if my image height is 0.6, then my object is going to be larger than the original image, and so the original object. And so this is going to allow me to create some salt characteristics. Okay, so that's what I'm going to do now, is I'm going to do my salt. So I'm going to do that in red. So my image characteristics for, so S, size, well, my image is larger than the object, so larger, right? When I look at attitude, attitude is upright or inverted. Well, compared to my object, my image is upside down, so I would say it's inverted for my attitude. Okay. L, location, so it is in front of the mirror, and it is, so I'm going to say in front of mirror, but it's also behind or beyond C. And that's, you know, that part is a little bit extra. So type, well, since my image is in front of the mirror, it is therefore a real image because it can be projected onto a screen. So, you know, that's a lot to ask, just putting all of those in pieces of information for SALT, the characteristics, to help you describe it. So I would recommend maybe creating a visual like this to help you. So at this point, we've gone through all of the problems for all of the mirror math. And there is an assignment waiting for you to complete, to work through, and to submit. The answers will be there for you, but I'm going to want to see your work. And so make sure you're showing all of your steps and your solutions. And if you're having trouble arriving at one of the answers, make sure to pop into our Zoom meeting and ask for some clarification.